Hi, back again. Um, this is an interesting concept that's not always, I haven't seen it spelled out that well or you can find out info on it and piece it together, but I haven't seen anything that really uh, lays this out regarding the daisy chaining of 555 timers. So, in a number of the experiments I do, that I've been doing, it's involved using one timer to trigger another timer to trigger another timer, etc. So, like one of the experiments I did was daisy chaining um, uh, 555 timers for cascading. You'll see this one, cascading LED lights. So I used several. I used four or five 555 timers to cascade different events. So timer number one goes for 1 second, timer number two goes for a half second, timer number three goes for a minute, and you're using staging, you're staging events with cascading timers. The thing is, one of the methods that they use is this method that you'll often see when daisy chaining 555 timers. This is a concept that I never really had to play around with. A lot of the timer work I do is with PLCs, so the component level kind of stuff doesn't I don't really need to work with. But this here, where you're using, like say in this example here, pen 3, which is the output of this timer, to charge up a capacitor to trigger a reset on this timer. Pin 4 is a reset here. But what happens is you're using a passive component, this capacitor, to charge up, and then when it releases, it sends a pulse, a negative pulse on the discharge down the when you're ready to trigger. It's not always intuitive, I found, to just put any old capacitor in there. You have to experiment a little bit. It's a little bit of trial and error, I find, depending on what components you're working with, like quality of the components, because you can't always get a good trigger off some of the values. And I was trying to find out information on how to zero in on those calculations. So if anybody has those calculations on how to best zero in on choosing the best capacitor in your designs, but the concept is what's important, and it's not always intuitive as to what's happening. So to really understand what was happening, I put it on the oscilloscope. I have a little oscilloscope here, and I really wanted to see what was happening. So what I've done is I've taken this section of the circuit, and I'm going to test it and actually see what's happening on the oscilloscope. So as you can see, there's a positive feeding a resistor, and that connects to, forget about this part. Let's just see what's happening in this section here between this resistor and this capacitor, because this is where I'm going to see the pulse. And then you have a capacitor, and the capacitor is going to be on this side, going from negative to positive, depending on the timer switch. The way this is supposed to work is it goes positive, charges up this capacitor, and then when it releases, when it triggers back, when it flops back to negative, that's when you get the pulse. And that's what I couldn't understand, because I thought, well, if this is positive here, wouldn't that actually be the sort of negative polarity trigger on this side? But it's not, and you'll see that in a moment on the oscilloscope. And as you can see, the way I've set it up is I've got a 33K resistor here. I got a 10 microfarad capacitor there, a ceramic capacitor, and then I've just sort of linked up a little. Basically, I've just linked this little wire here, because I'm going to go from positive to negative, and you'll see actually, and this is what obviously this is the point that I'm measuring on the oscilloscope. that's my ground, and that is the point between the capacitor and the resistor I'm checking on the scope. So basically, I'm just going to go positive, and then when we're ready, so that'll simulate the 555 timer doing a positive output, and then I'm going to go negative, and you're going to see what happens to that. Ooh, this might be a little hard with one hand, but I'll if you can bear with me a second, let me just reset this. So what we'll do is, okay, so I'm going positive now. Oops. Oh no. So I've already charged that. So we're already positive on the 555 timer, pretend. I'm going to do this again because it's actually a little something else going on. And now, after a certain amount of time, the timer output shuts off, and here we go. Bang. There. So it went from 9 volts, dropped right down into nothing, just like 1 volt basically. And anything under like 2 volts is going to trigger the next timer. So now I'm going to go back to positive. And as you could see, it actually goes positive so the other side of the capacitor actually goes positive when it's sent a quote-unquote positive output from the timer. And that was like sort of counterintuitive until you start thinking about what is happening actually electron-wise on a capacitor when you think about holes and fills. So now that capacitor is charged up, and to trigger the next timer, you have to go negative. You have to go low. It has to go low. So it has to go below 1/3 of the charge of the voltage. So basically anything under 3 volts, because this is a 9 volt setup, a 9 volt power source. So anything under 3 volts is basically going to trigger. It's going to trigger the event on the next timer. So here we go. Bang. There we go. Right down. That went right down to about 2 volts. That went right down to about 2 volts. You can see the 2 little dots there. And that will trigger the next timer. But like I say, and then now here it goes. We're gonna go positive again. Watch this. Bam. It actually goes positive. So that wouldn't trigger the next timer. But basically what it's doing is charging the polarity of that capacitor, and then when it's ready to trigger negative, and here I go back over to negative again, I'm going to do negative, that's when you'll get your trigger. Bam, right, that went right to 0. So that will trigger the next event. So as I say, as the timer's going positive, then negative, so positive, you're getting on, I'll just do that there. So as this timer goes positive output, so it triggers, it charges that capacitor. That's where you saw that bump up. But that positive charge wouldn't affect the next timer. That wouldn't affect the reset pin number 4, because that requires a negative. That requires it to drop, to go low. And so when this then, as this is charged now, when that timer shuts off, when it flops back to off, to negative, you get a surge of electrons on this side. Then all that negative polarity releases, and then this goes negative, and that's what's happening. And so that is actually what's happening on this what we'll call it a capacitive trigger on cascading 555 timers on daisy chaining. So if anybody's struggling with that, that is in fact what's happening. That's why they use it. So anyway, hope that helped. Bye.